today we are going to learn some other things like mass and weight. So first we learn about mass. What is the definition of mass? So it is a quantity, or it is the quantity, you can say. It is a quantity. It is a quantity of matter possessed by an object. It is denoted as by small m or capital M. So this is the definition of mass. Now SI unit of mass. Mass is kilogram. Short for dragon kg. The next one is mass is a scalar quantity. Because it has only magnitude. That means you can say it has magnitude only. Next one is the mass of body normally remains same. The mass of a body normally remains same. And fourth one is the mass can be measured with the help of beam balance. The mass can be measured with the help of beam balance. The next one is the mass of an object is independent of the mass of an object is independent of acceleration due to gravity. So these are the information related to mass. Now how to measure the mass, or how the mass of the body can be measured. So you can write how the mass of the body is measured. Okay, so it is measured with the formula of gravitational force, like F is equal to G mm by r square. Now you can see from the formula that G m by r square is equal to constant. So F is directly proportional to m. Now if I take two objects of different mass, m1 and m2, so from this relation F is directly proportional to m, we can write F1 is directly proportional to m1 and F2 is directly proportional to m2. So we compare this one, we'll get F1 by F2 is equal to m1 by m2. So this is the relation we found. Okay, so the mass of the bodies can be compared by measuring the forces of gravity acting on the two objects. The mass compared by these methods are called the gravitational masses. So how it will be measured? It will be measured with the beam balance. So to compare the mass of the two bodies, we compare the force of gravity acting on the two bodies. This can be done using the equal beam balance or two-pan balance. So now when the forces will be equal, then you can say that the m1 is equal to m2. So you can see the beam balance you have seen look like this. I want to stand like this way. So there are this type of things will be there. So there are one pan is there, that is called pan balance. So this side will place the objects and this side will place some type of weights will keep here, and standard masses will keep here. Standard masses 5 kg, 2 kg, 1 kg. Suppose I want to buy 5 kg objects, I'll place a 5 kg standard mass over here, 5 kg like this. Then I'll put the objects here. What are the things? When both the things will balance, so there is one pointer is there and it shows 0, then we'll just stop measuring. So we'll find out the mass of these objects, equating the mass of the standard, which is we'll put in this side. So that is the thing, that is the procedure to measure the mass of the object. So next one will go to the weight. So the weight of an object, first we write down the definition. The weight of an object of earth is equal to the force with which the object is attracted towards the earth. What is the formula? Formula is equal to W is equal to m into g. Now, what are the information you can get from here? That it is the SI unit of the weight is Newton. SI unit Newton, or you can write kilogram meter per second square, or you can write in this way kilogram meter second to the power minus 2. Now weight is having magnitude and direction, so it is having direction, so it's a vector quantity, vector. So weight of the object is directly proportional to its mass. You can write weight of a body is directly proportional to its mass. The weight of object changes from place to place. Okay. The weight of body changes with the value of acceleration due to gravity. Serious way than objects weighs more in pole than the equator. And next one is the weight of object is 0 at the center of the earth. And third one is the weight is measured with the spring balance. So mass was measured with a beam balance, it is measured with a spring balance. So remember that the weight of an object is higher at the pole than the equator. Weight of an object is increases in going from the equator to pole. The weight of an object decreases with height, and body weighs less at height than at the surface of the earth. Next one is that weight of the body is decreases with the depth inside the earth and becomes 0 at the center of the earth. Already I told you. The next thing is that an object on the moon weighs 1/6 of 6 that on the earth. Okay, so this is the things which you learned today, mass and weight. So you can write down the comparison, or you can say not comparison, difference between the mass and weight from the information which is provided. Okay, so thank you very much.